walk through number 17 on the 6C homework. In this example, we're looking at the height of men that's normally distributed. We are given a mean and a standard deviation. So when we go through to find which percentage for the z-score of 74 inches, we have to normalize that. So that's taking 74 minus 69.4 divided by the standard deviation of 2.9. So when I did that, I get 1.586. Round 2 decimal places as needed, 1.59. So 1.59. Now on this, we're doing multiple steps. We want to know the percentile. Multiple ways you can go about it. Probably the easiest setup would be to find the normal distribution. 69.4 and 2.9 standard deviation. We want to know what percentile what a z-score of 1.95 would be, which would be the same thing as a x-score of 74. So right here is a picture of a normal distribution given the mean as 69.4 and the standard deviation as 2.9. There's a few different things we could do since it should accept 94.37. If I convert this to a decimal, and then it looks like since this is a 5, I'm going to round it. So I would have 94.67. It should accept that, and I will actually submit it and show you. But depending on what you have, if you have a table and you're looking at the percentage score, you're not going to be able to get as precise, especially because we converted this to a z-score of 1.59. And you can see it's a little bit different here. We have what this would be. So if you submit this and check your answer, it should be correct. If you submitted the other one, it should be correct, and there should be some tolerance. So if you get the answer wrong, it should tell you the right answer, and then it should say plus or minus some given tolerance. That tolerance is important because depending on how precise your tool is, you might be off a little bit, and especially when you're rounding, if I'm using the z-score or if I'm using the normal distribution with the data points. This calculator is using calculus to compute this, and so you can see there's going to be a little bit more accuracy there, but you don't need this calculator. You can use a table once you find the z-score to find the percentile, and you would expect it to be relatively large because you're almost 1.5 standard deviations above the mean. So the next one we're looking at 67 inches as the point. It wants the standard score, it wants the z-score, so we know that this is going to be negative because I'm going to take 67 minus 69.4 divided by 2.9. So I take how far from the point is it from the mean and then divide by the standard deviation. Doing that I get negative 0.827 round decimal places. So negative 0.827. So that 7 makes that 2 a 3. So negative 0.83, right? Negative 0.83. So in this case, I'm going to use the z-score, right? So I have a normal distribution. I'm looking the probability that, or I'm looking for the percentile, which is the probability it falls below that, 68 inches, which then is negative 0.83. And you can see it would be 20.326%. I'm going to round 2 decimal places. So I'm going to say 20.33. So it wants it in a percentile. That's why you move the decimal 2 places. And then I get that is correct as well. So keep in mind there is that tolerance. In this example, we're looking for the percentage of the male population that's taller than 5'11". So you have to convert this into inches. So 5'11", So 5 times 12, 12 inches in a foot, plus 11 inches would say 71. So I can go to my calculator and I can change the probability to greater than. I can plug in 71, but if I'm going to use the data point of 71, I have to change the mean and standard deviation to what the mean and standard deviation is in the data points here. So 69.4 is the mean and standard deviation is 2.9. So you can see 29.066, round 2 decimal places. So I'm going to round that 5 to a 6. It wants it in percent. And I get the correct answer there, 5.4. What percentage is shorter than 5.4? So I got to do some calculations. 5 times 12 plus 4. And that's 64 inches. That's pretty short comparatively. I'm going to plug this in 64 inches, and I'm going to change it to less than. Now I've already have this set up to keep in the mean and the standard deviation. I'm going to round the 2 to a 3. I'm going to put my decimal there. So 3.13%. Now the last part here is asking approximately how many men would this represent? And you got to be a little bit careful because when you're looking at a population of 13 million, rounding can play a huge role in this, especially when we're going to look at basketball players who's 6'8" or taller, or a player that is 6'8" or taller. So 6 times 12 plus 8. That's 80 inches. That's pretty big. That's pretty tall. A very small percentage of that population is going to fit in that, right? We're looking for someone that is taller than, this is a tiny percent, right? And if I multiplied this without approximating times 13 million, it's going to get my answer off a little bit further than I want. So when I plug this into the calculator here, I want it in a percent, so I'm going to multiply it by 100, which moves the decimal 2 places. And this is 0.012%, right? So I'm going to change that, in that 8.5 could play a large role multiplying it by 13 million. So I'm going to put it as 0.13%. I've been rounding 2 decimal places, so maybe I'll just leave it as 0.1%. It wants me to round to the nearest hundredth. So let's leave it here. When I multiply that by 13 million, what do I get? 167,000. So 167,000, 13 million. Oh, sorry, that's my problem. I don't want to change it to a percent. So I want to leave it as this. It is already represented as a probability. There's no percent here. So if I change it to a percentage, I would have to then divide by 100 to multiply it by 13,000. So in this case, I'm multiplying it by 13,000, which is 1,670. It says round to the nearest 100. I'm going to go ahead and round it up to 1,700, right? So 1,700. And you should have some tolerance there. So again, be careful on this one that you don't put it in a percent to multiply the population. You want to leave it as a decimal, right? It's not asking you what percent. And it's true, a very, very small percent of the population is represented. If you want to know how many people that is, you have to convert that back to a decimal and multiply by 13 million, and then round to the nearest 100. So hopefully that answers your questions. If you have any more, please keep me posted.